Good morning. Uh, my name is Atharva Punikar, and I did Project 1 for the AP Physics 2 project. So I'm going to start with the basics about light. So mainly before the times of Thomas Young, people thought that light was a particle rather than a wave. Then came Thomas Young. So he was born June 13th, 1773. Then this is like generic stuff about his life, eldest of 10 children, child prodigy, studied medicine, but he didn't become a doctor successfully because he couldn't comfort the patients. He's mainly known for his contribution to the field of light through the double slit experiment. Now, about the experiment. This is the first experiment that gave evidence that light behaves like a wave rather than a particle. Basically, the way his experiment worked is he poked two holes into a film screen and enabled light to pass through the holes. Then what happened was, on another screen, there was a series of dashed lines that showed up, and that represented the space between them in order to form a line. So the interesting thing about these dashed lines that were presented based off of the light projected is they had a central maximum at the center at which the area was dashed. Then there was also no dash. It was a dark spot followed, and then the dark spot would be followed by another dash, which was a maximum. And basically, the maximums was where light was passing through. No maximum, dark spot, no light passing through. So over here is an image of how his experiment essentially worked. The way it worked is he cut narrow slits throughout this one metal sheet over here, and he would let light pass through. Then on a different screen over here, the series of dashed lines would show up. And as I mentioned, where the dashes were, that was where the light was focused on, and where there was no dash, that was the dark spots. So, an important thing about his experiment is the difference in the distance the light traveled to the screen, the difference between the screen from the center of the slits versus the top of the slits. So, the top of the slit versus the center of the slit is if the difference is precisely one wavelength, then the interference is considered a constructive interference. Now, if that difference is one half of a wavelength, essentially what happens is the two lights overlap and they cancel each other out, resulting in a dark spot. So, the difference between the lights itself can be identified using these specific steps. So, basically over here, synthesize a triangle. Is described over here. Synthesize a right triangle with the hypotenuse as the length of the narrow slit. So this narrow slit right here, that should be the hypotenuse that you synthesize with the triangle. We noticed that the shorter base side of the synthesized triangle multiplied by the angle, so there will be a shorter base since this is the hypotenuse. This will be the shorter base, and the angle between the longer base and the hypotenuse, that multiply is equal to the hypotenuse itself. Next. Right. So I just restated this, and based on that, we get these formulas over here. The distance, as stated over there, distance times theta is equal to integral times wavelength. This formula leads to constructive interference, and that is what gives us the bright central maximum of the dashed lines. We also derive a different formula, which is the distance times sine theta, same thing, is equal to n plus half times wavelength. Now this formula gives us a destructive interference. destructive where they cancel each other out and give dark spots, result in dark spots. I drew a wavelength myself to describe what the wave of light actually looks like. So where there's a local maximum, that's where light is being shown, and where there's a local minimum, that's where there's a dark spot. So another thing that he was able to do is, using the double slits, he was able to measure the wavelength of monochromatic light. So the wavelength is equal to displacement x times d divided by n. N is the quantity here, times the length between the two screens. And that formula is represented right here. I felt that this image was an accurate summary of what he had done, so I wanted to include it. It's basically everything I described.